In the fourth exercise of session 5, we are asked to extend our simple trap handler. Instead of just jumping over the instruction, we now also want to print the fact that an exception occurred, so that the user knew something went wrong, and afterwards still jump over it. So now our trap handler is going to be a bit more complicated. In fact, it will need to print the cause of the exception and the address where the exception occurred in code. Now, this means we're going to do some system calls from our exception handler. That also means we're probably going to need more registers than just the T0 register. We need the A7 register. We will need the A0 register to provide input to our system calls. So in this case, we figured out in advance that we will need 2 registers next to the T0 instruction. Next to T0. So we will need A0, A7, and we will also need T0. What's stated in the exercise assignment is you could, in theory, use the stack here in the exception handler, the call stack, as we did for function calls, to back up some certain register values. You could do this. However, it is possible that the stack pointer, for example, was the cause of the exception. It's possible that the stack pointer was misaligned. So, if that occurs, then you would have an exception within your exception handler, which is not something you really want to provoke. In that case, you're going to get into infinite loops, and you won't be able to restore from your program. For an exception handler, you shouldn't be using the call stack. A better way is to define a trap frame in a data section. So you could just simply define some memory in the data section. We call this a trap frame, and in this trap frame we will be backing up the old register values before the exception handler was entered. So the exception handler, in this case, most realistic trap frames will have entry for every single register and back them all up. Now in this case, we just reserved 8 bytes because we knew in advance our simple handler here will only need to save 2 registers. And I'll show you how we did this. So first, like previously, we first backed up T0 to use Scratch. We still need this, because we need to load the address of the trap frame in T0 before we can use the trap frame. Alternatively, you might have worked with a global pointer, which could also work. I'm not going to go into detail, but so backing up, we already have this use Scratch register, so there's always one register we can clear. And then using this one register, we can load the address of our trap frame, and then we can store the values of A0 and A7 right in that trap frame. We don't need to store T0 because T0 is already in use Scratch. And now after these lines, we have backed up both of our registers. Now we can print the first string, which is going to be exception with CASS. That's going to be printed using the print string system call. And then we're going to print the cause of the exception. The cause of the exception lives in the uCause control status register, as seen in the table here. So uCause, the user trap cause. This is an integer value, so we use the print integer system call. Print integer expects the integer in A0, that's why we write uCause to A0. And so after this line, we have printed the first part, so that would be exception with cause 4. Then we print the second part of the string, occurred at address with the system call. And then we just need to print the address where the exception occurred. And as we know, this address is stored in UEPC. So we load UEPC to A0, and we use the system call 34, which prints this value as a hexadecimal, because we typically represent addresses as hexadecimal values. And so just another system call that now prints the address of the exception as well. Then, lastly, as we did before, currently EPC is in A0, so now we add 4 to A0 and we store A0 back in UPC. What this does is we jump over the faulting instruction whenever we return. This is the same as from last exercise. Before we actually return, we want to restore all of our old register values. So T0 still has the address of the trap frame. We didn't change that anywhere. So we can simply load the values of A0 and A7 back from the trap frame. And then we can write the value of uScratch back to T0. All of our registers are restored. We used 3 registers, we backed them up and we restored them. And then we can just return, skipping over the faulting instruction and ending this program with an exit 0. So let's run this, and as we can see, exception with cause 4 occurred at address 400074. So this has worked successfully.